All right, thanks everyone for joining. I know there are people joining today from at least 4 continents and a variety of different time zones, so appreciate you all making it here. Before we start, I wanted to acknowledge that this is a period of civil unrest and injustice being done to many Black people in America and elsewhere. And I think it'd be wrong for us to not acknowledge that and continue going about our day. So I trust we're doing what we can in our communities, both at work and outside of work. And with this open source community, it starts with remembering that the world today impacts different people differently, and that we all should be extra kind and empathetic to each other, especially given the backdrop of COVID-19 when we do our work with others in the community. I wanted to check in if anyone else wanted to add anything on that topic. Okay, with that, I think it's a judgment call, but I think we should continue with our agenda for today. If any of you has any other thoughts, please feel free to reach out to me or any other member of the community. Cool. So with that, we have 3 topics for today. The first one is improvements to search relevance, which was done at ING. The second one was a CLI based on Amundsen, which is being shared by Robert Yee from Airbnb. And the third one is a data quality system also at ING called Popmon. So we're going to start off with the improvements to search relevance.
All right, thanks, Mark. Please let me know if you can see my screen.
Yep.
Cool. So welcome, everybody. Today, along with Damian, we will present on the latest improvements on the search in Amundsen with Atlas integration. So this is how we are providing the relevant search results to data analytics platform users in ING. And we'll start with just a brief introduction to DAP, because not all of you here might have already heard about it, and this is pretty much the context on how are we using and where are we using Amundsen in ING. So in summary, DAP is the data analytics platform, which is a cloud-native platform for data democratization. It's created to speed up the experimentation done by our scientists and analysts. It's developed internally in ING WBAA, so Wholesale Banking Advanced Analytics, which both me and Damian are part of. And its main features are the horizontal scalability, the latest open source technologies, obviously, and end-to-end security, because after all, we are a bank. And the landscape of the technologies we are using is pretty broad, but we are proud to say that a part of it is Apache Atlas and Amundsen. So the data discoverability part of that platform is based on those products. And today we'll mostly focus on how those two work together. So in the data assets, which both me and Damian are part of, our mission is to help our clients to identify, assess, secure, and deliver data, regardless of the type of the information and how is it stored. And obviously, the part of this is also enabling a great data discoverability service to the users. So how are we using data on DAP, and what kind of data we have, how we use it will be the topic of following slides. So we mostly store data on HDFS. We use a Hive Metastore as our central repository for tables. And every user gets a dedicated DB, and every project gets a dedicated DB. So the latest stats on how many entities or objects we have is above 80,000 tables across 400 databases. So this is a lot of metadata, which we will be enabling our users to browse. And with such amount of metadata, obviously, the challenge of finding the relevant information arises. We also discovered that distribution of tables across the databases is not very uneven. So because of legacy processes might create a new table every day, it results in entity overflow. And actually, We have one database which is responsible for 34% of our entities, and 10 of those databases make up for 90% of tables. So not very even distribution of tables across databases, and a lot of tables means that the challenge of finding the relevant ones becomes very difficult or more difficult, and with such amount of information, we had to find a way to for Amundsen to be more return more relevant data to users. And to do that, we also had to establish how the data is accessed on the app. So we have 3 entry points for data. There is a data science in a box project, which is a dedicated big data environment with Spark. Every user gets its own Jupyter Lab instance and accesses the data in this way. We also have the Apache superset for business intelligence analysis, and Presto as our big data SQL query engine. But we have one security tool to cover all of those cases of accesses to data, and this is Apache Ranger. So in the recent months, we thought that it's about time to introduce a popularity score to the Atlas and Amundsen integration, something which was very desired and missing in our solution and was already present in the Amundsen with Elasticsearch and Neo4j solution. So how to resolve the problem of finding needle in the haystack with that couple of technologies? We define the popularity score as a measure for establishing whether the table is popular or not. So the more users query the table, the more popular it becomes. We use the popularity score as a global search relevancy measure. So as another step, we would like to also find a way to return results based on some more narrowed context for the user. So global searches will be the same relevancy measure for each user. And we are using Amundsen formula as a starting point. We are using Apache Ranger audit logs to leverage the information on the accesses of data to come up with this popularity score. And we schedule basically the Spark job with Airflow to update our Atlas entities with the latest popularity score. And for that, we are mostly using the HDFS logs. All of our data currently is stored on the HDFS. So we use Ranger audit log for HDFS, which returns all the accesses to files stored on HDFS. Because we want to tie this information to our tables, we query the Hive metastory in our Spark application to somehow enrich the logs with the information which table it's regarding. And the numbers on our HDFS logs is around 250,000 audit events daily, which we parse and extract information from. That's the ballpark of what's the measure of that. And to make Amundsen and Atlas work with the popularity score, we had to make some changes to both, actually, and together with Damian, we will walk you through them today. So I will start with changes to Amundsen. We needed to extend the Amundsen Atlas types with popularity score and attributes. So Amundsen Atlas types is the definition of all the entities required for Atlas, and Damian will give you some broader context on that. We obviously needed to enable sorting by popularity score on all queries in Amundsen, which, together with adding support for advanced search, sounds like an easy job. And just by looking into the number of merge requests we had to file to make it happen, it seems like it was easy. But each one of them required actually a couple of changes to the Atlas code, and that's why the task wasn't as trivial as it seems. And now I would like to hand over the presentation to Damian so he can brief you on what actually was required to be changed on Atlas side so we are able to work with the popularity score.
Yeah, hello there. Am I audible?
Yes.
Great. So here it is, the ING case study for the metadata governance for the banking industry. So I would like to briefly mention the major challenges you can think of where trying to implement the catalog of the financial data assets. First of all, we required the suitable storage for the metadata. So we need to think of something that reflects the structure of the metadata, including the attributes, relations, labels. The next step would be the search engine to actually to enable users to explore the metadata with the suitable search methods. Another thing, it needs to scale and needs to be pluggable so that we can get a proper interface to manage, to interact with the metadata. And as we are in the banking industry, that needs to be secure. So what was the approach? The graph database is the perfect choice for representing the metadata. It gives us nodes with attributes and relations. It needs to be pluggable, so we need to incorporate this to our current architecture, including the data ingestion process and reflecting the changes from the data storage. It needs to be scalable because we expect actually the daily increment of the data. So right now it's about the 80K tables and about 3 million columns, and the daily growth is also growing day by day. It needs to be transactional because we expect that multiple concurrent clients would interact with this storage. And we need also the search capabilities. That basically means that we need kind of a technology which enables the free text search and which can be used somehow to apply the search relevancy, as this is the main context of this presentation. And it needs to enable the authentication and authorization. In our case, we can probably distinguish between the different roles, like the data owner or data source owner, the team collaborators, and read-only users. So right now, and the last thing to actually consider is the maturity of the technology. So right now, I would like to focus on the two major players by considering the graph database. On the one hand, it is Neo4j, which is, I think, the most mature technology available on the market, versus the Janus graph, which is which has growing community. It was created a little bit later, so actually it has half of the stars comparing to the Neo4j and half of the contributors. Let me compare these two things in a little more deeper way. So let's think about the backing storage. So for Neo4j, it is actually the native graph storage, which is like a dedicated storage for the Neo4j. And in other case, in the Janus graph, we can use HBase with replacement of Cassandra or Solr, and alternatively Elasticsearch. So there are a couple of ways to do that. Considering the transactional isolation, for the Neo4j, it's strong consistency. Basically, it supports it's reliable and supports the full ACID model. On the other hand, Janus Graph, it depends on the backing storage. It is eventually consistent by default, but you can enable the locking mechanism as a trade-off of performance. Moving on, about the scalability, Neo4j is not scalable in the community edition. So I'm not sure about how it looks like about the pricing for the commercial license. On the other hand, Janus Graph is elastic and linear scalability available as in the open source version. For the search performance, it's comparable. Actually, on the one hand, it's directly the Apache Lucene. On the other hand, there is Solr or Elasticsearch. It's comparable. For the graph queries, it's not so relevant right now. And talking about the authentication and authorization, it is supported for the Neo4j only in the Enterprise Edition. And for the Janus Graph, it's about the backing storage. So in case of HBase, you can probably set up Kerberos protocol. For the authorization part, you can also plug it Ranger over here, as this is a part of the Hadoop stack. So finally, we decided to use Apache Atlas, as it provides most of the features which were mentioned before. So it is a set of foundational services on top of the Janus Graph storage. It supports a push model. So basically, there is the Kafka consumer available, which can consume all the changes coming from the original data storage. It has the extensible type system. I will briefly describe it later on. It has search capabilities based on Apache Solr and REST API to interact with it. It supports the data lineage, so we are able to track the transformation from the data source to the target place, and it also incorporates the tag propagation. So what we are basically trying to achieve is to reinforce the data governance with the data discovery by applying Amundsen on top of Atlas. So how to make it running? You basically need to define Amundsen Atlas types, which is kind of the extensions to the predefined definitions of entities. We just released the version 1.10, which should be used because this is the latest one and it's stable and is fully integrated with the Amundsen search and metadata service. So we started to implement this by trying to use the relational attributes. So essentially, you have one entity corresponding to the Hive table and another entity corresponding to the Hive table metadata, which contains, for example, popularity score. And there was the relations, but essentially that was slow because Atlas doesn't support the usage of indices for the relational attributes. So we decided actually to denormalize types and to plug it as the super type. So you have the Hive table, and you can define its super type to be a table, which extends the set of primitive attributes by additional attributes like popularity score for the tables, or column statistics for the column. We also include the bookmarks and the readers, but this is not the topic for this presentation. And I encourage you to play with that. It's available under this GitHub repository. And the last thing I would like to mention is actually our journey to make it running and production ready involves to create a couple of PRs to the Atlas repository. It includes the improvements to the performance of free text search. It was essentially slow, so we moved from the in-memory filters to filters applied on a solar site, and this is like 10 times faster than before. We enable sort by attribute to actually sort by popularity score. So this was kind of the major issue while trying to sort result in Amundsen by the popularity score, so to apply the search relevancy.
Hey, Damian, sorry to interrupt. If we could wrap this up in a few minutes so there's time for questions, that would be great.
Yeah, this is the last slide for my site.
Great.
And we also enable sort by for search by classification. So you are actually able to sort the results while trying to find something by the tag. And right now, this is not fully implemented. It's about transactional isolation, and it requires some configuration on the Atlas side to actually enforce the high consistency over the Atlas storage, and we actually observe some duplicates over there in the rare cases. So so this is kind of an issue right now. So so last thing, if you would like to use Amundsen with Atlas, you need to actually use the master branch, because that contains all the changes requires to make it running. And this is it from me. Mariuz, would you like to summarize it somehow?
Mariuz, you're on mute.
Sorry. So just to wrap up our roadmap for the next changes for the Amundsen, since we already have the popularity score, we want to have some filtering on the entities before calculating popularity score. So right now we are not excluding any entities from calculating that, but probably we want to exclude, for example, test databases or some redundant obsolete tables from it, because they are now appearing quite high sometimes in the results. We want to include the programmatic descriptions. We very much like this feature in Amundsen and want to embed it in our discovery part, because people are very frequently asking about those kinds of information. And the third thing is to somehow enable data quality in Amundsen. And we're looking into Popmon, which is a subject of another presentation. So just to say that it's on our roadmap, and that's why also guys from data science team are also here. So that's basically what's in the upcoming future for our data discovery. And this is the questions part. Thanks.
Well, thank you. There was one question from Usher: when to add something as an attribute to a type versus when to use attributes on classification and Atlas.
The popularity score is obviously an attribute, because that, as Damian said, it enables us to sort by it, and it actually would be difficult to sort on a classification, for example, if we would make it a classification. The classification is a good idea where you, for example, have to propagate something over the lineage. So imagine you have a S3 bucket which has a classification called managed, which is that means that this is a secure data, and then you want to propagate this classification over every entity which is a part of lineage routing in that object. So that would be one case. We also find classifications to be a good use case for giving some meaning for the data. So, for example, users frequently ask us, is this a payment data, is this a transactional data, stuff like that. So, and the security is one part, and another one is just like broadening the context on what the data is actually, what is actually the meaning of the table.
Thanks. In interest of time, we can take any other questions on the Slack channel. Thank you, Damian and Mariuz. Next up is Robert.
Yeah, hey, thanks for having me. Let me try to present. sorry, this is weird. Oh, I see. Maybe the next person can go first. I'm having some trouble with presenting.
Okay. Was it the presenting problem?
Yeah, I just have well, it's Google first. All right, give me like 30.
Okay. Seems like you need some Chrome permissions. Is Popmon team ready to talk about their work?
Yep.
Okay. So why don't we go first and Robert can go at the end.
Yep, sure. One sec. There we go.
There you go. Can you guys see?
Yeah, can you see the screen?
Oh,
Hey, Robert, is it okay if you go after Popmon?
I'll go next. No worries.
Okay.
Can you see the screen?
Yes.
Yeah, good. Okay. Yeah, so I'm Max Baak. I'm one of the chief data scientists in Bolker's team. And together with Thomas Sostak, he's also on the call, actually. Over the past year, we created this package that we open sourced last month. It's called PopMon, which stands for Population Shift Monitoring. So our tagline is Population Shift Monitoring Made Easy. So thanks for inviting us to give a presentation about this. So let's go straight ahead. Yeah, so what is PopMon? It's a package. It's a Python package that allows you to monitor the stability of a data set over time or over increments. And you can do it. You can use it in Pandas or in Spark. So what allows you to do is that to detect changes over time, for example, things like trends, or shifts, or peaks, outliers, anomalies, could be changing correlations between features, etc. And if you see that those things are happening, then alert on it based on either static business rules or dynamic business rules derived from the data itself. Yeah, so let me move on. So why did we make this? We actually, some of the machine learning models that we have in production that we're using in our department, they were not being monitored carefully enough. So beginning of last year, we decided, okay, we need to fix this. And we did not find any good open source solution available to do this, and also nothing commercial that we as data scientists were satisfied with. And as it happens, I used to be a physicist. I used to work at CERN on one of these experiments that discovered the Higgs boson. And when I was there, together with another team, together with a team, I was responsible for doing data quality monitoring. And so we would record hundreds of gigabytes of data per week. So I was involved in checking that all of the data that new data was correct, that you could use it in your analyses. So I have a lot of sort of past experience and sort of crystallized ideas on how to do this right. So we decided to build it ourselves, first for just one model, and then we decided, okay, let's generalize it and open source it. So that's where we are now. Anyway, when it comes to monitoring, and I mean monitoring of machine learning models that are running in production, there are actually three facets of it that you need to consider. If you look at things like I don't know if you're familiar with packages like MLflow or Kubeflow, if you look at the type of monitoring that they do on models that are being used and that are being trained and retrained, it's what we call performance monitoring. So, for example, it may have the accuracy or the performance of a model, machine learning model that's running in production. It's being retrained maybe every week, and the numbers, say the new accuracy on a new incremental training set, that is being captured and is being stored. But there are two other very important components, which is that you need to check the data that is sort of newly incoming data that's being fed into your machine learning models, to see if that is consistent over time. And the other thing is quite related, but it's checking that the predictions that are coming out that those are consistent over time. Because if they're not consistent, if you see changes in the incoming data, or if you see changes in the predictions, you know that your model is off. And it could be that your model is giving wrong predictions, or it's giving suboptimal predictions. And you will need to dive into why that's happening, and you'll need to fix it and rebuild your model. So anyway, if you look at like existing packages like MLflow, Kubeflow, they really tend to focus on performance monitoring and not really on any advanced data or predictions monitoring. So PopMon really focuses on the data monitoring, so the input data, how is that consistent over time, and also the predictions. And let me show you why it is important. Here you see a data set that is changing over time. Now, if you look at existing packages that do look at data monitoring, very often it's quite basic. So they look at things like what is the mean of a distribution, what is maybe the width of the distribution, or the min-max values. So standard data profiles. That's what you see here at the bottom line. In the middle, you see what the actual data points are, and you see that those are changing. But what you are seeing over time is that the mean, the standard deviation, and the min-max of the distribution are actually not changing. Whereas the histogram of the data is actually changing quite a bit. But like the standard data profiles are not changing over time. But the point that I want to make with this sort of little animation is that you need to do monitoring of the entire population to be sure that the data is consistent over time. Because if you do these basic profiles, you don't capture everything. So what we do actually in PopMon is that we do monitoring based on histograms of the data. So we turn these sort of incremental data sets into histograms, and we do histogram-based comparisons. Working with histograms has another benefit, that they're small, they're not privacy sensitive normally. So anyway, so let me show you what we do. To give you an example, what we do, let's say you have a year of data, some kind of feature, a categorical feature, which has values A, B, C, D. And over a full year of data, the data set looks like this. But we actually have this data in increments of a week. So we have week 1, week 2, etc., all the way down to the last week. And week 1 looks like this, week 2 looks like that. So let's actually take a look at week 1. Week 1 looks like this. Then we get the next week of data. It actually looks a bit different. It looks like this. Let me overlay these two things. Then you can see that they look like, that they actually look different. That they look different. I can also look at the difference of these things. You see that they are quite different. What we do is that week by week, or sort of time slice by time slice, we perform statistical tests to look at, are those histograms, are those distributions of data changing over time. So we do a bunch of statistical tests. No need to go into detail here. They're sort of standardized tests that anyone has, some experience in statistics will know about. But we do those to see if the data is changing on time slice by time slice. But we can also look at, is the new data consistent with an existing reference data set? That reference data set can be sort of historical data set, or it could be like a rolling window, it could be an expanding window, or it could be the past week. Then there's another thing we do, which is to illustrate how we can do sort of dynamic alerting on data. Let's say we have an input data set here on the left. Oh, well, it's the figure on the left. We can take a look at all these values, are these bins, all these bars that you see. If we can plot those in a histogram, then you get the distribution here on the right, like the normal shape distribution. From the distribution, our value of interest, maybe it's it could be like I don't know, mean of income, mean of amounts on transactions, something like that. Anyway, from the distribution, we can determine what is the typical value, that's mu, and what is also the level of variation that we see in this distribution. And then we can sort of go, let's call it 1 standard deviation. We can go out with, say, 4 standard deviations or 7 standard deviations. And whenever we see like a new increment in data, and we get a new our new value of interest for that particular day, for example. We check, is how consistent is it with the previous data set? Does it fall within these boundaries? Does it fall within the yellow boundaries? Does it fall within, or is it even beyond the red boundaries? And based on that, we give either a green traffic light, a yellow one, or a red one for that particular time slice. So if we have new data coming in,
you have about 5 more minutes.
Yeah. Okay. Oh, sorry. I will hurry up. Anyway, based on new data coming in, you can show does it fall within these boundaries? Yes or no? Yeah. How do you use it? I'll be very quick. Just to pip install it, and if you import the package, then if you look at like the second to last line, you can call df.pm stability report, and you need to specify your time axis or your batch index, and it generates a report. Or if you want to see it in one line, you can do this, import Popmon, and based either on the Pandas or Spark data frame, you can run this line, it generates a report. Let me quickly show you how such a report looks like, because that is the nice thing. Why is it not showing? There we go. Yeah. I can show you, this is our GitHub page. There's a link there here at the bottom with some example reports. I can show you one now. This is a report on a Kaggle data set with some air flight data. If you look at the top, you see there are several menu items. We have profiles of the data, so those are all the features in the data set. Here there are 6 of them, like airline, whatever. So here I've picked one, airtime. You see that it keeps track of things like counts, distinct, filled, the maximum value encountered, the mean, min for particular weeks of incoming data, the most probable value, the number of other numbers, various quantiles. All of this is automatically calculated. And you also see these traffic light boundaries on them. And so you can do that for every variable. We can also look at comparisons, and with comparisons, we are actually looking at, for example, trends in the data, but we can also compare our current data slice with the previous data slice, the previous one, or we can compare, and based on that comparison, we can do things like chi-square test or all sorts of statistical tests. We can also compare with a reference data set, which could be a historical data set or a rolling data set. And again, we get these entries back, which indicate, for example, these weird peaks, that you have weeks that are really non-consistent with your reference data set. We have these traffic lights that I spoke about earlier. You have green, yellow, or red. Depending on these static or dynamic business rules, it can you can get all the data is green. We can have stuff that is red, so that's something you want to look into, or yellow, which is fine. We can also aggregate all these traffic lights to get alerts. So, for example, this is the number of green alerts for all the variables together. So a lot of it is green, but sometimes you also have red alerts. And you can, of course, tune whenever something is red or not. Whenever something is red, you probably want to look into it. Or we have the number of yellow alerts. And then you can take a look at, how does the data actually look like over the past weeks for particular features. Okay, let me quickly get back to the presentation. Here I was, so I'm almost done. We've applied this several times ourselves for our own models, and here you can see an example of one of our models where we applied the monitoring. We saw there was suddenly over the year of data was a huge spike here in the middle, and also we saw like a bump in the end. So what is that? This is a great way of sort of doing root cause analysis, diving into the data, seeing what is wrong. So we saw this big spike. Turned out there was a switch to a new data source around that date. When we were training our data, our model on the full data set versus just training on the new data only afterwards, we saw actually a huge improvement in the performance of a model. So this is a very nice way to illustrate how you can use this monitoring to actually make your model better. Similarly, you see a bump here at the end was a similar issue, but I won't dig into it. Anyway, I think Popmon is really nice for two things. One is exploratory data analysis, but also you can use it for this batch-wise updates of a data set. So I think those are the two main cases. Next things we'll do, so we have the intention, and Mariuz and Damian already mentioned it, that we will integrate this with Amundsen. And for now, we'll be doing more PR. So last slide, please go check it out. We think it's very useful. Thanks. That's it.
Thanks, Max. Any quick questions here before we go to the next presentation? All right. For any follow-up, please talk to Max on the Slack channel, and then we will go to Robert now to talk about the CLI based on Amundsen. Thanks, Max.
Cool. Can you guys see my screen?
Yep.
Awesome. Great. I'll open my slides. Sorry about this. Let's see. There it is. Sorry, guys. Technical difficulties. Oh, there it is. Yeah, so I'll be pretty quick. I just wanted to share with you guys something I've just been building in my spare time. I'm a data scientist at Airbnb, but just as a disclaimer, I'm just building this sort of for fun. Yeah, so I made this command line tool built over Amundsen and using Fuzzy Finder called MetaFrame. And so I guess to motivate the problem a little bit, I'll talk briefly about, I guess, the typical data science workflow. I'm sure you guys are all familiar, but I figured I'd sort of motivate the problem a little bit more clearly. But typically at your company, you'll go through this data discovery phase. You'll use tools like Amundsen, or at Airbnb, we use our internal tool, Data Portal. And like at this point, you'll do some basic SQL exploration, usually in either the command line or with a web GUI. I think it's pretty common to use like Superset. They have a pretty nice web interface for editing queries and running queries against your database. And then you'll do your deep exploration, your ML, also on web. And so for a while I thought that I was in the minority. I would actually do things mostly in the command line. I'm like a heavy Vim user, and I just it kind of drives me crazy to have to edit text in a web GUI, especially if there are no Vim bindings. So I thought I was in the minority. I started asking around a bit and found that a lot of my friends actually preferred using the command line for editing SQL. And so I figured, that probably means that you don't want to also go to the data portal or like Amundsen and have to context switch if you are in the command line, at least for like really basic cases, right? Like if you just want to remember what names, what sort of column the table has, it's a bit of work. It's not that much work, but I figured, how hard would it be to say build a port from Amundsen or a data portal into a command line interface? So as a sort of good worker, I did the exercise of asking myself, how much time will this save me, and how much time is it worth to work on this? So I figured I'd actually probably save about a minute a day, and so really I should only work on this for a day if I want the returns to be yielded in 5 years. And I figured if I can get other people to also use this, then maybe it's worth a little bit more time. And so I said, forget it. I'm just gonna build it. It sounds fun. So that's the story behind everything. So yeah, I'll go through a little bit about what sort of additions I made to Amundsen or Amundsen. Sorry, I don't know how to pronounce it because I only read it. And as well as Fuzzy Finder and sort of a command line, or to the file structure to enable this. But first, I guess I'll briefly say I made a few data builder modifications. This is primarily like a data scientist's like personal documentation tool, so it doesn't actually need to always extract like all metadata. So I made this engine class, which at some point I might merge into the main repo, but I just figured it's a different enough abstraction that I should just keep it on my own thing. But it allows, it's like basically an extractor, but allows for more flexible querying. You can run multiple queries against a single extractor, which means that with the ETL task in Data Builder, you don't even have to, like instantiate a new task in order to run a new query. So I also made a Neo4j extractor, so that way I can, you can actually, it's like it supports Neo4j Amundsen style natively. So you can just, if you have a Neo4j instance running and you're using Amundsen, you can just pull your metadata from there straight into the command line interface. And I also created a loop extractor, which is essentially leveraging the engine class to loop over Presto without having to access like information schema or the metastore. And the last thing is a markdown loader. So I'm saving all these files from the ETL job as markdown. So it has some syntax highlighting and it's easy to see. And I made some small fuzzy finder modifications. If you guys haven't checked out fuzzy finder, you absolutely should if you're on the command line a lot. And finally, it all sets up this like file-based metadata structure. So I'll give like a quick demo. Let's see, hopefully this will work. I have a local Neo4j instance running. Usually you'll run like mf-init. Oh, I don't have directories. Okay, cool. And then you'll run mf-etl, and this will just run like an ETL job, which can take insanely forever. I'll address why this might be a useful pattern in a sec, but you can run this from Neo4j. It's pretty fast. And then when you type mf, you can actually just get a nice catalog of all of your tables. So if I put some dummy tables in this database, but so if you want to look for hobbies, you can look for hobbies. If you want to look for students, you can just look for students. And you can scroll up and down on these. And you can, the kind of nice feature I added is you can add like, I guess, enriched personal documentation, which is really what data scientists often need. Like you want to like attach your queries to a table. You want to save like notes about things. So you can, in Markdown, just add things like, a custom README. I can say like this table was backfilled on 2020-0401, and I can add some SQL. Select star from, I forget what table this is. I think it was students or hobbies, but hobbies, there you go. And then when you go back to it, you get this sort of enriched field at the bottom here. So, that's basically it. Everything is defined in, like the connections are just defined in YAML. So you can just go to mf connections edit and you can specify everything about your connection here. You can also do something like, type Presto. Currently it supports Presto as well. Your, AWS EC2 instance, et cetera, et cetera. And I've also added a few flags just for quality of life for data scientists. This is an interesting tool, but I realized that at least at Airbnb, we have like millions of tables, I think at Lyft too. So pulling all of this in like through a local ETL job is a really bad idea. And like the fuzzy finder will start to chug really heavily if you just have like a million files that you're searching over, right? So I've included a few extra options, and I have a GitHub repo that I haven't really shared yet, but you guys can check it out. I have on a Gitbook page. I just really like Gitbook. Oh, by the way, I made all these like things like logos and fancy docs, but I just like doing that. Don't take it as an indication of production readiness of any of this because it's probably not quite there yet. But feel free to try and let me know. But yeah, I've added extra options like for Amundsen, you can include specific keys. So like if you pass a schema key or a database key, it'll include only those databases and schemas. You can also exclude explicitly like massive junk schemas. I know like a lot of tools like like Looker with their persistent derived tables will create a lot of like artifacts and store them in your warehouse. So this is maybe a way to get around that. And I've also included like the ability to pass regex, regular expressions, as well for filtering. But yeah, that's mostly it. Cool. And let's see, I should give the GitHub link. Yeah, go here. Give me stars because I am completely motivated by fake internet points. Sweet.
Awesome. This is great. Thank you, Robert.
Yeah.
Any questions for Robert?
Cool.
Damian asked, do you plan to support Atlas backend?
Yeah, I'm thinking about it. So at Airbnb, I know they use, they largely just use like their own, like the architecture is very similar to Amundsen, right? It's like Neo4j with Elasticsearch. But they do have like an Atlas server also running for governance. I think it'll depend. If there's enough like appetite for it, I'll absolutely support it. Why not? Just post an issue and I can do it. But a lot of this is also like, I told you guys, I'm just kind of doing this rogue. So I'd have to like figure out how to set up my own Atlas server and then test against it, which is really like the bottleneck in all of these things. Yeah. Yeah, happy to give it a try.
Thank you. Cool. Thanks, Robert. Any other comments for the meeting today? Anything someone wants to share, or any ideas for next meeting? Now would be a good time.
Maybe. I was thinking about sharing some of the user experience research that we basically Parisa has been doing for us.
Yeah.
Might be worthwhile for you guys as well. Some overlapping stuff, but also some new things, I guess, to a certain extent, and we can question her maybe.
Yeah, that sounds phenomenal.
I'll ask her and see if she wants to join. She says, I'm forcefully volunteering her now, so she doesn't know yet. So let me confirm with her first before I say it. But I would say that she would be happy to do so.
Anything else from anybody? All right, awesome. Well, thank you to the presenters for the great presentations, and thank you everyone who joined from various different time zones. We'll see you in about a month. Stay safe. Bye.
Take care. Bye-bye.
Thanks.
Thanks. Bye all.